Hi, this is Chen Lin, and I'm here with my partner Lin Fan Gao, and we're gonna talk about mechanical analysis of alleviating impact by bionics of woodpeckers and its applications. So here's our content. We will firstly talk about why animals create vibrations and our motivation, mathematical analysis, and talk about the woodpecker. Then we'll discuss about could animal vibrations hurt itself, and finally applications.
The relationship between biomechanics and vibrations. Animals and vibrations are much more related in our nature. Birds using their vocal cord to vibrations to express information to other birds, and rattlesnake, they shaking their tails to warn other animals to far away. And kangaroo, they jumping anywhere, and how they can jumping so fast and how they can absorb the shock, the vibrations. So the relation between animals and the vibrations are much more related.
Okay, here's our motivations. Firstly, it is just our personal interest. And there are many types of helmets on the market, and they all have different principles. And also we like to watch like football game, like racing game. So they all have helmets. That's why we like love this topic. And because of this, helmets have become a necessary accessory. So yeah, that's why we talk about this topic. Okay, so who is Triarchopus pileatus? And it is a genus of large, powerful woodpeckers. And it typically have 35 to 45 centimeters in length. Yes, this is the picture of that. So as you can see, it is the huge woodpeckers. And you can see that in like North America, Canada, and Mexico. Yeah, this is the structure of its tongue.
Here is a video showing the slow motion of the woodpecker. Alright, from this two slow motion video, we can know the woodpecker, they can do 0.5 to 1 millisecond for one-time pecking, and they can do 20 times per second and 12,000 times per day. So the minimum of their brain can hold the G force is 4,000 G. The maximum for human beings is 3,000 G. Which means if human get the vibration, get the force more than 300 G, so I think the human will break their skull, get the concussions, and the eyes burst. So from the first video, we can see when the woodpecker, then they peck in the tree and they close their eyes, because if they didn't close their eyes, the inertia what makes the eye to blow out.
So how it work? I'm gonna divide it to like 4 parts to describe why it can protect itself. So first one is school structure. They have thick screw and like special body structure. And also they have large contact surface between brain and skull. And it's interesting that they have spongy bob. And actually the dense sponge bob of the woodpecker's head can disperse the impact when struck. And it also has the effect of damping. On the surface of the brain, there's a layer of pure matter. There is also a layer of arachnoid outside the pure matter. The space between the two layers is called the subarachnoid space. The cavity is filled with cerebrospinal fluid, or like CSF. The woodpecker's subarachnoid space is very small, so there's a very little cerebrospinal fluid, which can reduce the shock waves transmitted through the liquid. And yeah, we can see that the structure, the shape, and the position is very different from like woodpecker and people. And second one is body proportion. Like we can see that the woodpecker has small head and big body. So that means brain weight surface area ratio is small. What does that mean? It means that small impact forces are spread over the relatively large area. Many of these forces are sustained by the body, not the head. And also, the top lip of the woodpecker exceeds the bottom lip by 1.6 millimeters, while the upper teeth are 1.2 millimeters above the lower teeth. Third part is precision angle controllability. When the woodpecker hits the wood, the beak hits the wood almost perfectly vertical, so there will be no lateral stress. So also we can see the rectilinear motion that avoid injuries caused by tongue. And they have short impact time while like pecking the trees. And members of eyes, transient concussion, and increased stress. Well, that can temporarily congest increased stress and keep structures like the retina in place. And okay, the last one is tongue. And yeah, we can see that the tongue of the woodpecker is special, and it is like has excellent deformability and toughness. After surrounding the skull with this structure, it is equivalent to providing a perfect shock absorber for the brain. And this shock absorber can absorb a large part of the vibration generated by pecking, protect the woodpecker's brain, and avoid concussion.
And the picture in the right side is we using the SolidWorks to simulate the tongue of the woodpecker, and the tongue is holding its brain, so we can see the reaction force in different times in 0.6 millisecond and 0.8 millisecond to the 15 millisecond. So it's about the one period of the pecking. So we can see the reaction force and how the deformation occurred in the tongue.
This figure is the effective stress distribution of woodpeckers' head during pecking. It is simulated by SolidWorks. So we can see that for the brain, there's almost no stress on the brain. So yeah, almost like 90% of the stress is absorbed by the tongue. Yeah. Okay, so what is shock absorber? A shock absorber or damper is a mechanical or a hydraulic device designed to absorb or damp shock impulses. It does this by converting the kinetic energy of the shock into another form of energy, typically heat, which is then dissipated. Most shock absorbers are a form of dashboard, a damper which resists motion via viscous friction. And yeah, there are a lot of areas using like shock absorber, like suspensions on vehicles or motorcycles. And yeah, we can see the construction sector, like the damper inside the building, and finally the safety field, like helmet. And we will focus on the helmet, like safety field.
All right, here is a video showing the seatbelt slow motion analysis. I know in the scenario design, there's some group there, they are doing the seat belts. So that's why we download from the website and showing the slow motion of the seat belts. So the brown part is like the human beings, and this line is like the seat belts, and this like a tongue to hold the woodpecker's brain. And here's the mathematical analysis. The g-force measurement of the relative acceleration is equal to F equal to ma. Volume and mass dropped by the cube, and the surface area drops by the square. So we know small mass of the brain with the specific big area makes the woodpecker didn't get the concussions. So we can get the equation of the pressure is equal to the g-force divided by area. Or for the absorb shock, woodpecker brains are also surrounded by a thick plate-like spongy bone. This characteristic of the bone help it absorb and lessen the force of the impact. From this picture, we can see there's a lot of space among his spongy bone. So it's more like the coil spring to reduce the acceleration and the vibrations and absorb the shock. So this space could help the woodpecker to absorb the shock and to reduce the acceleration. It's more like coil spring in suspension application.
Okay, here's the question. Could animal vibrations hurt itself? Well, the answer is absolutely not, because from the sophisticated head shock absorption system, this is a coordinated effort of all parts, not just rely on any single factor to achieve it.
Here's a video showing the why car's suspension is important. So this video is showing a vehicle go through the bumpy road. So let's see that. All right. From this video, we can know when the vehicle go through the bumpy road, so the shock given by the bumpy road. So we can the motion is pretty similar to the woodpecker pecking the tree. So if the woodpecker don't have they didn't absorb the shock, it's like the vehicle don't have the suspension, so they will get the accident, and the people whom are sitting in the vehicle will feel very uncomfortable and in danger. And here's two pictures. Well, we can see in the left side the picture, which is the vehicle don't have the suspension. So let's say what's the motion, the slow motion of this vehicle to across the bumpy road. So if a car without the suspension, so when it's go through the bumpy road, we can see the junk motion. And on the right side, if we see the car adding the suspension, so let's see what direction. So we can see the direction, the jump direction is very small. So that's why some good car, they should have the very good suspension, and how suspension protect the human who's sitting in the car, and how suspension equipment to absorb the shock and regulate the vibrations to protect people, like the woodpecker. Their spawn is like coil spring to absorb the shock to protect the woodpecker's brain. And for the vibration applications, the suspension is the most important application we learn from the woodpecker. Functional decomposition of the suspension is the first one, absorb shock and the steering stability, damage prevention. Fourth one, regulates the vibrations, and the fifth one is support weight. There's two main types of suspension in today's world, which is the McPherson suspension and the double wishbone suspension. Whatever the two suspension is different, but the principle of them is same, which means to using the coil spring to absorb the energy, to absorb the shock, and to regulate the vibration and protect the people who are sitting in the car.
Okay, here's another application like protect people's life. And as we can see, there are football helmet and like regular scooter helmet and a bicycle helmet. And the inner layer of high density styrofoam, which has strong shock absorption ability, is the same as the dense spongy bulb of the woodpecker. So yeah, that's the same principles why like people can save their lives as same as like woodpecker save his life.
And another very important application is seat belts. Seat belts is to like the tongue of the woodpecker to hold the body, to hold the woodpecker's brain, to reduce the acceleration, to absorb the energy, and absorb the shock. Or the conclusion of this project, we can see there is three total reasons to make the woodpecker didn't get the concussion and didn't get hurt. The first one is the woodpecker have the strong screws, which is like the helmets in our daily life. Another one is the porous spongy, which is like the suspension and the coil spring, the suspension to absorb the energy, to absorb the shock. And the third one is cartilage is like seat belt to hold the people, hold the body, hold the brain. So in my opinion, second choose is more valuable than posits choose it. This is a saying by the Albert Einstein. So what is science? Science is what people learn from the nature and apply it to life. Nature is pretty attractive and beautiful. So humans have much more things they need to learn from and analyze it. So that's what engineering students do, and that's why this course have this project and make students do a lot of research on it.
So here's our references.
Thank you.